Let's see, what music do we play? Ooh, let's go Utada Hikaru this time. Hell yeah. Okay, so yeah, that's enough. I was checking the answers to these. For the most part, it was okay. It was okay. I mean, I got the answers correct, but the reasoning either I didn't even provide, and when I read it, it wasn't the most clearest thing ever. So yeah. Also, I mean, like, if anything, I have like biology and chemistry to like continue on, so I can always just take a break from this, and it won't really affect me, especially because like I'm gonna be continuing on domains with this teacher, so it's okay. I'm not too worried. Can Okay, so yeah, that was the issue. For the most part, like for example, well, actually, some cases I didn't even check what the natural domain was. First one is not even a domain. I mean a function, sorry. Second one is going to be this, and each value in the domain is going to be that. I said 1 to 6, so that's fine. Range I said is -1 to 9, that's fine. So this is fine, this is fine, I think this is fine. Oh, another reason why this doesn't work, this definition, okay, I need to chill out on the text. This is fine, and this is also fine. But over here, it's not just this, there's one more reason. And that's, it says that the entire input, all the inputs of x is going to be r, okay? They said for all inputs, I mean, it's not going to be a subset of r, it's going to be the entire set of r. And so, can the entire set of r be used to give an entire set of, can all of the real numbers be used to give all the real outputs? No, because over here you can't give any negative numbers because, well, you can't have a negative square root. So we're using a subset of the real numbers. It's not just real numbers. It's gonna be a domain of the real numbers. So yeah. That's also another reason why the domain itself is not it's not defined on the given domain of R. I think that's my understanding. Then C, question number C. So it is a function, and I said the natural domain is of all the people who lived. Over here they mentioned that the domain is going to be P and the range is going to be the subset W consisting of the women that have had biological children. I wrote that the range there was no range. Okay? So obviously these things need to be improved. So look, if the domain is going to be the set, if the domain is going to be a subset of the it's going to be a subset of all the people who lived. That's what the domain is. Okay, so what is that subset? It's going to be the people who are alive right now. It's going to be P. Okay, then W is going so now what would be the range of the outputs, right? The range of the outputs would be if the output of W. Okay, so I said no range because I was like, okay, it's just going to be woman, either living or dead. That's what I was kind of confused because okay, no. See, the natural domain. I'm mistaking this. They're asking what the natural domain is. They're not asking what the universal set or whatever is. Okay, they're not saying what is the domain a subset of. They're just saying what is the domain. Okay. Now the subset is probably going to be all the people who lived. Okay. I mean, sorry. Like I don't know what this set is called. Is that called the universal set or something? But the equivalent to this in our question is probably all the people who lived. That part is true. But the natural domain of this is going to be P. Okay. Now the range is just W. I said that there was no range, and in this case, it kind of makes sense why I said that, because there is kind of no range, but the range does exist, and it's from W to W. It's gonna be from there to there. Okay. Yeah, 1-to-1. My understanding of that was fine. Then D, I was also correct on this, on everything practically, but except for the fact that I didn't prove I was 1-to-1. No, we weren't supposed to, I don't think, but it probably would have been better to prove why it's 1-to-1 rather than just saying it was 1-to-1. For these ones, it was kind of more understandable because it was kind of like a more verbal thing. This one can be expressed in numbers because it is like a, it is a function, which makes sense, right? So it's like, how could we do it? So if we look at the function, we're saying the f of x is going to be 2 minus root x plus 5. And we're saying that, we're trying to prove that it's going to be 1-to-1. So how do we prove that? We have to prove that it's 1-to-1 by saying if a and b if a and b are equal, then they would have the same output. Okay? Or if the product of A and if the output of A and the output of B are equal, that means that A and B have to be equal. If they aren't, that means that if A and B are not equal, but their outputs are equal, that means it's going to be a many-to-one situation. Okay? And it's not 1-to-1. Okay? So let's see. If I said 2 minus a plus 5 equals to 2 minus root b plus 5. Okay, because we can't pick any two numbers, we have to just write the variables. There's no other way of doing it. Then we add in a 2, and I guess, yeah, just like multiply everything by minus and multiply everything by minus and subtract 2. So then you'll be left with a plus 5 equals to root b plus 5. Then square everything. A plus 5 equals to b plus 5. Subtract everything by 5. That'll be a equals to b. So that proves that it's going to be 1-to-1 relationship. Okay. If and only if a and b are equal, then the outputs will be equal. Otherwise, it will never happen. Now, the last one I get entirely wrong. Okay, and the reason for that is because I think I didn't find the domain correctly. Okay, so, and I just learned this actually just recently. Just now actually, before even checking the answers to this question. And it was by the black pen, red pen guy. I think that's his name. And so you're gonna start off with, of course, it is going to be a function because each output, has a reasonable, each input has one real number output. Domain of hx is the set of all x values for which this. Okay, so now they're trying to find out or define what the domain is. So if we say that now if you want to find out the domain, it's pretty easy. Just find out what the range of the x values that you can use, and the easiest way of doing that is equating this denominator to 0. So I guess just I don't know how else to explain it. You have to do it like this. So then you would find out that x is not equal to, or x cannot be equal to 2, right? Which means that if you place it on a number line and you have 2 over here, you have to think of a hole over here, and then everything that is less than 2 is allowed. Everything that is greater than 2 is also allowed. Okay? So therefore, as you can put this in terms of a sequence, in terms of notation, proper notation, you can say this thing, x less than 2, greater than 2 and less than 2. Okay? Or you could put this in the other way where it's like What does open brackets mean? Is it closed or open? I think it's open. So you would do, because because the domain has to say like where does it leave, right? I mean, like, I guess this also works. I think this also actually works. But another way of writing it would be like negative infinity and 2 union 2 positive infinity. Okay? And then the range of the values, remember, it cannot be 2. So then what the range of the values would be everything except 2. Now would it be plus minus 2? Yes, it would be plus minus 2. So it's not as simple as this. There's actually more to this. So because okay, if you did step by step down, this would have been okay. So if I did x squared is not equals to 4. Now in this situation, if x was 2 squared not equals to 4, that would work. Minus 2 whole squared not equals to 4, that also works. Therefore, x is going to be equal to plus minus 2. Okay? And if it's plus minus 2, then if we drew the graph again, sorry, we're having a minus 2 and a plus 2. Remember, you're going to have holes here. Okay? And now, well, you're going to be having minus infinity to minus 2. And then I believe you're allowed to be in between here. I can simply use, let's say I put in 0. 0 minus 4 is not equals to 0, so that's fine. So yeah, so I think you can go there. So I'm going to give a union minus 2, 2, union 2, infinity, and beyond. And I think that's fine for the domain. Now, as when it comes to the range, since we can't have minus 2 and plus 2, well, that's only gonna be 4. That means we're gonna be having every value except for 1 divided by 0. Okay, let's see. No, we can't have plus 2 and minus 2 as x, right? So on the number line, what does it mean though? It's like what's on the y-axis, right? Could we do it like that? Should we do it like that? I don't know. Okay, think of it this way. You're going from minus infinity and you're stopping at minus 2. Minus 2 over here would lead to that. What is going to be minus 1 here? Minus 1 is going to be 1 minus 4, which is going to be minus 3, 1 over minus 3. So like this, and the other one is going to be then minus 1 to 1. So that's going to be over here would be minus 3. Minus 3 whole square is going to be 9 minus 4, which is going to be 5. 1 over 5. And then over here is going to be minus 1. and here is going to be 1. So minus 1 whole square is going to be 1. So 1 over 1 minus 4 is going to be 1 over minus 3. And then the other one is going to be positive 1. So that's going to be again minus 3. So 1 over minus 3. And then, you know, this leads to infinity. This is going to be plus 3. And this is going to be just infinity. So plus 3 over here would be 3 to the square is 9. 9 minus 4 is 1 over 5. So really it's, I guess, just this and this. I'm not sure actually, but yeah, we'll see. The domain is the set of all x values for which x squared minus 4 cannot be equal to 0. So therefore the domain of H is everything except x plus minus 2. Now to find the range, we must find y values that can be expressed in the form of y h of x for some x value. Now solving for x in terms of y, we obtain 1 over y plus 4. I'm gonna. Did I say this was not 1-to-1 or 1-to-1? I didn't mention it. Wait, does each of these examples have a... okay, yes, they do. Oh, Allah. What is this square? Okay, so this is fine. That's gonna be kind of your domain. So kind of this, but this is kind of taking it too far. We can kind of end over here. Now, but for the range, this is where the problem is lying. So if we're having this, then we know that this is equals to y. That means we know what x will be equal to. X will be equal to... This is fine. This is kind of the method for finding inverse of... No? Okay, this is correct. Now, as long as y doesn't equal to 0 and y has to be greater, has to be non-negative essentially. So to find the range, we have to kind of substitute 4x. And substitute hx as y and then kind of find the value of x. But what does that tell us? When we do this, when we go from, this to this, what does that actually tell us? Let me just make it very clear so that I can like send a picture of it to Gemini. To find the range of this function, we have to substitute the h of x into y and then find out the value of x. But I don't understand what is this substitution actually doing to help us find the range. Now the original function takes an input x from its domain and produces an output in its range, so y is equals to h of x. Now if your inverse function, if it exists, would take an input y. Okay, yeah, so we are taking an inverse function, great, okay. So now an inverse function, if it exists, would take our input y and output the original input x. So x would equals to h inverse of y. So if you had h of x is equals to this, okay, now let's say you wanted to make another function to find out what the input would be from the output. Like over here, we're finding the output from the input. Rather, we're finding the output from the input. Okay. So that's why it's on the left side. Okay. Okay. Well, whatever. This is unknown, and you're trying to plug in the known to find the unknown. Now, over here, okay, we're trying to find out the input from by plugging in the output. Now we know what the output would be. The output is going to be, no, we don't need, okay, sorry. We're gonna plug in the range of the using the how do I do this? We use this to find out the range of outputs. But just for context of what this is, okay, this is just an inverse function of the original function. What does it allow you to do? It allows you to plug in the output to get a value for the input. So let's say we plugged in this original equation, let's say we plugged in a 2 over here. Okay, no, not 2, sorry. A 5. So then you'll be getting 5 squared is 25. 25 minus 4 is going to be 21. So then h of 5 would equals to 1 over 21. Okay. Now over here, now we're getting the y is equals to this, right? So that if you plugged in, this can also be written as x is equals to h inverse of y. So then if you inputted the output that you got 1 over 21, then you would get square root 1 over 1 over 21, which would just equals to 21, plus 4, which equals to 25, square root 25, which equals to 5. Therefore x equals to h inverse y equals to 5. And guess what? The input that we were using was 5. So this is what we think it is. Like that is, yes, okay, that's true. Now what? This is not good because it just loops. it goes on for 2 days. It's only a looping 13 songs. I don't get it. So why do people do this? Um, anyways. Just turn down the volume just a tad bit. Okay, so now the steps you've shown are precisely about deriving the x, blah blah blah. Swap xy conceptually, the step usually done when formally finding the inverse function. This is perfectly fine and often more direct for finding the range. You're effectively asking for any given output y, what must have the input x have been? So then you actually do it. Now this image only shows the positive square root. True, but we'll address that in a moment. How this helps you find the range. So the expression that you derived essentially tells you for what values of y can I find a corresponding valid input x. To find the range of the original h of x, you need to determine all the possible values that y can take. Okay? Similar to how if you wanted to find the domain of the function h of x, you need to find out all the possible values that x can take. And you did that, right? By solving the denominator and what cannot equal to 0. Same thing you have to do here. What values can y take here? So so then you know that you can't have y equals to 0 because it's 1 over y, right? And then you cannot have a non-negative under. You have to have a non-negative under the square root. So then 1y plus 4 has to be greater or equal to 0. So let's just quickly do that before just looking at what they wrote. Therefore y is not equal to 0, and y 1 over y plus 4 has to be greater or equal to 0. So then y is going to be equal to 1 over y minus 4, 1 minus 4y, and then y. We could just do this. Y 1 over minus 4. Right? If we did this, and then did this, and then did this, and did this, yeah. Let's just quickly do that, so that'll be then right? Or a much simpler way, and then just right. So now you have this and you have this. So now you know that y can go into negative infinity, y can go into positive infinity. So then maybe perhaps you could write it down like has to be greater than or equal to minus 1 over 4. It cannot be negative, so it can't actually go into infinity, negative infinity.
Wait.
Um, okay, wait 1 second. Since it cannot equal to 0, then do I write 1 here? I'm not sure. Okay, let's see what they wrote. So 1 over y, okay, and then you have case, you have to consider two cases. Y is going to be greater than 0 or y is going to be less than 0. So for y is going to be greater than 0, if y is positive, then you can multiply both sides by y and flipping the inequality sign. Okay. And if y is negative, then you can flip. Then you must flip the negative, the inequalities when multiplying by y. Combining with y is going to be less than 0. This gives let's see, Fazan. When you have a negative inequality, okay? I mean, sorry, when y increases in the negative direction, this actually becomes smaller. And as it becomes smaller, this just reaches 4, okay? And so, essentially, it's okay. You can go negative infinity. It's no problem. Let's say we went... yeah, I mean, yeah, no matter what. You can go positive infinity, negative infinity for y, and it wouldn't change anything. If I went positive infinity for y, and negative infinity for y, you would start off with, let's say, like negative 1 over 1, so that would be 3. And then you would just keep on getting smaller than 3. I'm sorry, no. You'd be, then you would, the number that's going to be subtracting 4 is going to be getting smaller and smaller and smaller. So you'll be reaching from 3 to 4 indefinitely. Then if it's the other way around, y is going to be greater than 0. And say y is first like 1. 1 over 1, 1. So 1 plus 1 plus 4 is 5. And then we did 1 over 10. And so it's going to be 4.01, right? Or no, 4.1. And so it's going to get smaller and smaller and smaller until it reaches 4, right? Indefinitely. So in both cases, you can go negative infinity and positive infinity. That's not the issue. Oh, Allah. But you need to know that y cannot be, if we're saying y is greater than 0, y has to be greater than, okay fine, I'm stupid dude. Okay, I need to relax. Okay, so they reach this inequality whenever y greater or equal to minus 4. Now y is positive, so you can multiply both sides without flipping inequality. I have no idea what this means. Okay, so there's a rule straight up that y has to be greater than 0, right? I mean, sorry. Y doesn't have to be greater than 0, y cannot equal to 0. Is that a typo? They're combining the number lines, right? I think. Y has to be greater than 0, y is less than 0. If y is going to be greater than 0, then we need to ensure one thing. We need to ensure that 1 over y plus 4 is less than, is going to be greater than 0 as well. Okay. So then what we're doing is if 1 over y, so in our first thing, we're saying that y is going to be greater than 0. Now if we're saying that if 1 over y is going to be, 1 over y plus 4 is going to be greater than 0, then y is going to be, it's going to be greater than equal than 0, because it can be 0. Y is going to be greater or equal to 1 over minus 1 over 4. And if you combine this with this equation, then y is still going to be greater than 0. Why? Because if I drew the number line, you had 0 over here and negative 1 over 4 over here. And we're saying that y is going to be greater than 0, and y is also going to be equal to, but however, this is not going to be included. Okay, but if I did this on a separate line, then we have negative 1 over 4, and this is going to be included. And if you combine these two, you see that going from here and onwards, and here and onwards is just going to be equal to x is going to be, y is going to be greater than 0. Now if we did this with the second case where y is going to be less than 0, now also you can write this as I think, and this is the second case, so then you would write it as, I mean you already know that y is going to be, so then so except for this, y is all these values, and then 1/4, oh that's going to be negative, including this, all the values, combining that together, you'd be having y is going to be less than or equal to negative 1/4. So then you can also write negative infinity to negative 1/4, and I think you can have a closed bracket in this case. And so then you can finally write that down as I should probably okay, let's see. So then in combining both cases, y is going to be less than or equal to 1 second, y is going to be less than or equal to negative 1/4, or y is going to be greater than 0. So in interval notation, this will be written as minus infinity, negative 1 over 4, union 0, infinity. Addressing the plus minus for x. Now the image shown shows x as square root 1 over 4 plus 4, 1 over y plus 4. However, when you take the square root of x squared during the solving process, it should be plus minus. This has changed the range, not for this particular function. The range analysis depends only on the expression under the square root and the denominator, not on whether the x itself is positive or negative. So in essence, by solving for the terms x in by solving for x in terms of y, you're identifying what constraints y must satisfy for corresponding x to exist. These constraints then define the set of possible outcomes, which is exactly what the range of the original function is. So yes, it's a lot more than meets the eye. Yeah. The following function, f and h, have domains marked in blue and on the x-axis, and the range is marked in red on the y-axis. What the hell is going on? Okay, I see. Right. It would form an asymptote at x equals to 2, yeah. And the range negative infinity to negative 1 over 4, and then 0 to infinity. And the domain, as you can see. Now, domain minus 5 to infinity. What question is that? Okay, that's going to be D. Oh god, my eyes hurt a lot. Oof, damn. Good. Okay. So yeah, looking at the previous question, was the f of x? 2 minus root x plus 5, so x has to be, x cannot equal to 5, minus 5, sorry. I think I did that by the hole in the graph. I'm not sure. Oh, it cannot be negative either. Oh, sorry. And the range would be negative infinity to 2. Why? Because if it's going from negative 5 to infinity, that means this negative is only going to get even bigger. And it starts from negative 5. I mean, it starts from, yeah, negative 5, which would be 2. So then it will be negative infinity to 2. So then you would just describe it as this kind of graph. So you're used to seeing graphs without like a starting and ending point, but it's actually a lot easier than you think. Like you don't see it often, so you're like, huh, is this something complex? But it's not really. It's not really. Got. Val-yew climax.
এটা ঘুরাইছে কে?
আমি
কেন?
I can do push-ups without hitting the bed. Also, it looks better. Kind of. Do you have?
আমি এটা দিয়ে এক্সারসাইজ করতাম। এখানে আমার এখন না।
Val-yew climax. Sing. Sing, sing, sing. Sing a song. Okay. When I'm done, no? Okay, fine. It's 11 o'clock. It was a lot harder than it looks. Maybe should I ask for more like, example questions? Let's keep going. I mean, it's okay. I think it should be fine. It should be fine. How does the example question, I mean the answers for these questions look? Are they as in depth? Let's see. They are not as in depth now. Answer to all problems. It's just straight up not possible. Remember life is, it's not possible. And don't you try to make it possible. You know what I'm saying? Alright. So then, okay. I'm gonna just zoom in really big. Okay, no, we can't. I mean, can we? I don't know. Okay, fine. So ex2, given that the f of x is equals to this, evaluate f2, fa, fx1, and fx plus 1 and f of x. Okay. So first of all, f of x we know is equals to x root 3 minus x. Thank God this is a bit easier. Okay. So then 2, 3 minus 2, which equals to 2 root 1, which is equals to 2. This is going to be a root 3 minus a. Can't simplify that any further, I don't think. This is going to be x plus 1 root 3 minus x minus 1, which is going to be equal to x plus 1 2 minus x. Then now we're going to input this into this, okay? This is going to require a bit of pooping. So now we're going to have x root 3 minus x square root 3 minus x square root 3 minus x. Okay? So what does this evaluate to? So we're going to keep this as is. I think we can. For now. Anyways. 3 minus x. Or can we? I don't know. Okay, fine. And then inside the square root, we're going to have 3 minus x root 3 minus x. That's fine, I think. What does square root inside a square root look like? I think I've done this one time before. Root 2 equals to some weird number. Root 2 times root 4, which equals to a number which makes sense. Yeah. Can I go with this any further? Okay, well, okay, here's another thing that we could say. So this is a multiply here, right? X times root 3 minus x. All of that is going to be times by this. So we can just say that, no wait, if I say 2 times 4 times 3, that's going to be 8 times 3, which is 24. 4 3s are 12. 12 times 2 is 24 as well. So we can say 2 times 4 times 3. That's also possible. So then we can say that x times root 3 minus x times this whole thing. Now can I simplify this? Can I turn this into something? I can turn that into which I can write as right? For this I need to understand one thing. 4, if I wrote square root 6, that equals to square root 3 times 2, which also equals to square root 3 times square root 2. The square root 3 times square root 2, what does that equal to? Square root 6. So this is true. If that is true, then I can say that x can be counted as a multiplication. But now we're counting this as its own bracket, but that's not true either. It would be more like just this separate thing, like you have to keep a boundary between this and this, I think. Wow, remember that live stream? Lixian TV interviewing that one guy who created that game? With the candle or something? Yeah. I have no idea why that came to my brain. That was a long time ago. It's like a live stream. I think I was watching it live. I don't know why it was, but it was. Okay, let's say another thing then. Let's say is it possible? No, right? Yeah. That equal to something else. But whatever I'm doing here is possible. Okay, so now. So, what do I even do? If I multiply square roots together, what happens? Square root 2 times square root 2 makes 2. So then if I multiply this with this, what happens? What about square root 2 times, okay, but square root 2 times square root 3 would make square root 6, but square root 2 times square root 2 would make 2. So now I have to be careful about what I'm multiplying. can square root 3 plus x be written as square root 3 plus square root x? Okay, relax. Chill out. Yeah, I could have probably just proved that, yeah. If let's say we wrote 1, so square root 3 plus 1 would be equal to square root 4, which equals to 2. And then if I did square root 3 plus square root 1, that equals to square root 3 plus 1, which is not equals to 4. Okay, fine. Relax. I'm not sure where I'm going with this. Alright, let's see. It doesn't simplify further. Okay. Well. Okay. So the first one is going to be 2. Second one is going to be a3 minus a, yep. Next one is going to be x plus 1 root 3 minus x plus 1, which he didn't dive in further than that, okay. It's going to be this square root 3 minus this. Okay, yeah. I reached that. There's this bit over here. This thing. So yeah, okay, cool. I don't know why my font is getting larger. Like, why am I going at this size? But at the same time, it doesn't really matter. So let's get rid of this. This is going to be correct, and correct. Now if we look at example 3, finding a good graphing window. So using a graphing utility to find out a graphing window that accurately represents the key features of this. So do I have to, what is a graphing utility? What is a graphing utility? Okay. So then I could just Desmos, you are my graphing utility, you know that? And my favorite one as well, you piece of shit. Yo, bloody blanter. Come on, don't fail me now. God damn it. Can you make it into text that I can copy paste into Desmos? Goat. Okay. So now What do you want me to do, mister? What the hell is a graphing window? Like a range of x values? Then we can go from here to here. No. What the? That goes so fast. It doesn't go accordingly. Why is it going back down? And then it just teleports. Oh, this is so much fun. Whee! Wow. 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 You can never beat it. It's always gonna be faster than you. I mean, it's always gonna be perfectly timed with you. If you think you're gonna reach someplace before it, nope. Oh. Okay, I'm losing that. What the hell? Okay, sorry. We can pick from here to here, because it's gonna continue rising anyways from there to there, so it's not like it makes any difference. We know it's gonna go into infinity, so we can say a good graphing window is from here to here. But I don't even know what a graphing window is. What is a graphing window? Set by x min, x max, y min, y max. For many functions, especially complex ones, the interesting parts, like the intercepts, turning points, asymptotes, might be far away from 0, 0, so if your window is too small, you're gonna miss it. Oh, okay. Think of it like looking at a camera lens at an infinitely large landscape. So the graphing window is going to be the frame that you're going to be seeing through that lens. So, okay, I'm going to say so we're going to be going I'm just gonna say like, let's say x min, or let's say xy min, xy max. So, okay, wait, but they're not together. Okay. X min, x max, y min, y max. So x min is going to be -1, or I guess you could say like whatever this is, -1.3. Sure. I mean, taking -2 is kind of a bad idea because you would have to go all the way down here. All the way, actually, no, you have to go all the way down here. Sorry. I mean, it's kind of, yeah, close enough. But, yes. Oh, but since we're going here, okay, fine. So I guess over here would be okay, right? Like just seeing like this box or something. So what would this be more than -3 or what? So let's go like -2.5. Okay, so here are my first guesses, and then I'll give my second guesses. So my first guess was obviously just writing -1. And x max would be 6. Then y min would be so y min is this. Y min is going to be -30.04, and y max is going to be 6.04. Am I on my full black? Sorry, full white. Okay. But if I change my color, that actually changes as well. Does that change the white? Probably not, right? Maybe a little bit. Okay, no, it doesn't. Learn. Okay, now my second. Okay, now I'm too lazy to do another guess, bro. It's gonna be my final guess. So, holy shit. Okay. Solution: the three graphs that follow this. Each of these windows is bad in the sense that they show the true behavior. In the sense that the true behavior of the graph is not represented. X is supposed to go from -3 to -3 to 7. -3? Brother. Okay. And -40 to +40. I wrote -30 plus 6. Graphing window utility. Maybe Wolfram Alpha? Yeah, I think Wolfram Alpha is gonna have it. Wolfram Alpha always has cool shit like this. Can I customize? Bro, please. Is this the wrong graph? No. Okay, so this is a bad one. this is a okay one. This is a bad one. Because now you've removed the max and then, which is really funny how that works. Okay, but how do I change that? What the hell? Oh my god, wow. Oh wow, man. I love that. Liam. Hi, Liam. I don't know anybody named Liam. Plot. Okay, let me ask for them. Let me ask my brother, my friend, and my brother from another brother. Oops. Okay. Don't be weird. I feel like if I'm always nice, I'm gonna be taken advantage of. I don't like pretending to be the nice artist and always ignoring trolls. Whoa. Scroll up. Y'all thoughts on this convo? This is how I render hair now. Yeah. Pass. You don't have what it takes to draw hair. This is how to render hair. Now drawing is a different thing. Cannot draw with color, only with pencil. No one really cares that much on the difference between two terms. Here I am without clue how to actually draw hair. I don't know, go somewhere else then. You realize this tutorial isn't actually drawing hair, then you come in with this attitude. He didn't have any attitude, bro. You're just over here, I think. as you always do. If you want to know how to draw like me, you gotta ask nicely and I would have taught you. Yeah, you are going crazy over nothing, my friend. You call them out in your story? Oh boy. I like a chance to yell at someone. That's something. Oh god, you're weird. I quit art. I'm gonna become a Pokemon Go master. Did you know Wayland's middle name is actually Pika Pika Pro? He's gonna be the very best. The best there ever was. Dun, 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 dun. Marting X whaling. Be careful, you're getting pregnant while you sleep. Stay safe. I will. Hey, hey, hey. Oh god, Kobe actually said that shit. That is so funny. Snow on his shoulders. Oh my god. Oh, it's got really loud. Oh god, so stupid. Bro woke up at set time to Wayland all over this. It's whaling time. And wailed all over the place. Oh no, I messed it up. What's the thing? It's called, oh yeah, I forgot. Nope, oh, whatever. Don't do anything. Don't do anything about that, man. Okay, so there you have it. This question was interesting. Good window has to show the local behavior of the graph. I was just wondering what would the graph look like with this, with these things. Maybe I could ask ChatGPT actually. It's possible. Hey, using Wolfram Alpha, could you plot a graph with the viewing frame of x min equal to -1, x max equal to 6, y min equal to -30.04, y max equals to 6.04. Come on, GBT, come on. I believe. Oh. Okay. Hey, that works. Hey, that 100% works. Bam. Please. Oh. That looks fine. That looks 100% fine. I should probably pirate that thingy again. I forgot what it was called, Mathematica? Yeah. But yeah, I think this is an okay graphing window. You can see the max, you can see the min, you can see the interval. You can see the rising. You can see the rising. You can see what else? I think that's all really. Over here, the difference is just, what even is the difference? It's just, you can see it go past the x-axis. Like you can see it go down the x-axis, whereas over here it just stops at the x-axis, which I guess is not good. We should be able to see it a little bit more. For now, we will use a trial and error method to find an effective graphing window. We will be able to be more systematic after you have learned about derivatives and function behavior. Now, sketch a graph of a function that has the following characteristics. Approximate the location of the inflection points on your graph. Given the graph that you sketched, find the intervals. Interesting kind of question. So x4. So now, okay, let's actually do this way. So -2 and 1 and 3. So -2, I'll just keep this. So -2, keep that here. 1 and 3. Then we can say the local minimum is at x -1. local maximum at x equals to 2. Yeah. Sorry. Now a horizontal asymptote at y equals to minus 2. So from my understanding, it looks kind of like this. Yeah. Approximate the locations of the inflection points. I'm not sure what I don't know what inflection points are. I think it's like the points in between. So it's like this and this. No, I think it's just this and this. So is A, B is going to be. Should I be even solving these, or should I just be reading through these? I don't know actually. I mean, because I solved these in my own maths textbook in school, so it's like approximate the locations of the inflection points. So, well, they said approximate. I don't know, dude. Anyways, I'm just gonna say minus 2. X is equals to minus 2, minus 1. Sorry, and 1. And given the thing, find the intervals for which f is going to be positive, increasing, decreasing, concave up. So, I don't know what concave up is, but I know what positive, increasing, and decreasing is. So, positive is going to be this and this. So we can say write it like this. So positive is going to be from negative infinity to negative 2. Maybe I can give a union, I don't know. Then I can write 1 to 3. Should probably write down the things. I can't write anything else. I don't think so. Oh wait, did I even count? Oh wait, whoops. Okay, fine, whatever. We don't know where the y is. For anything. We only know where the x is. For anything. So we're only going to characterize this by the x-axis. Okay, increasing is going to be from minus 1 to 2. That's it. Decreasing is going to be negative infinity to minus 1. And 2 to positive infinity. It's gonna be going like this until it's just flat. And is that considered decreasing? I think so. Why not? Let's say it's definitely not increasing, that's for sure. Concave up, I'm just gonna say it's gonna be an interval between 1 and 3. Okay, so now this is what the graph is supposed to look like. Did they tell us? Oh shit, they did tell us. God damn it. Wait, no. Yeah, how did you know it was gonna go this deep? Reflection occurs where the... Okay, but besides that, it's fine, right? Yeah. These are locations in our graph. These points. These points are also locations of the steepest part of the graph. Oh shit. But they said local maximum. It doesn't. It's unnecessary that this needs to be deeper than this, right? I said local minimum. If it was, I forgot what the term was, global or something. Then I would be able to find this needs to be below whatever. This needs to be below y minus 2. But at the same time, I kind of agree. I mean, it feels right to keep this lower than that. So okay. So then this goes down, and then you write down. This is gonna be. Oh, sorry. This is 2. This is going to be 1. This is going to be 1, this is going to be 2, this is going to be should probably just get rid of this line. Okay. Okay, so the function f is positive on negative infinity 2 and 1, 3. Increasing on negative 1, 2, decreasing on negative infinity, negative 1 and 2 infinity. Okay, notice that all of them, they're using just circular brackets. So for intervals, always just use open brackets, okay? And then concave up is going to go from negative infinity and to half. So negative infinity to half. So negative infinity to half x. So like over here. No idea why that is though. And 4, infinity. The inflection points on this graph occur where the concavity changes from u to upside down u, or vice versa. These locations are where the graph flexes. So Okay, yeah, that does make sense. So over here would be here, and with the moment it starts to change, it's probably like, okay, it's straight, 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 and then it starts to curve. So we're probably going somewhere over here, which is like, they say it's here, which can be argued, yeah. Because remember, okay, we're going from this shape to this shape, right? But this is never going to rise up. But whatever, it's the start. So imagine at some point. So then, if we're having those two shapes, where is the meetup of those? And that's going to be somewhere over here. You could also think of it as connect this point over there, and you're just, that's going to probably be 4. Okay. So if I did half and I just continued it, that's 4. So yeah, yeah, that makes sense. Yeah. Though, yeah, it's approximately there, so it doesn't need to be exactly right there. Right, the domain. Okay. So first of all, second of all, that's going to be -1 divided by -2, which is going to just equals to 1/2. I believe. So combining both of these, therefore x has to be greater than half. Therefore the domain is going to be, I believe it's probably just going to be this, right? Oops, yeah, yikes. Okay. Okay, so they're doing that thing, okay, fine. But in this case, why? See, in this case, we're saying x has to be greater than 0, right? No, in this case, we're saying x has to be greater than 0. In this case, what if you said x has to be less than 0? Is that, I don't know. Or are we trying to do something else? Are we trying to say that, so we're taking that at the end of that, we're trying to take this number line, okay? Okay. And we're having -1, and you're having like half, whatever. Yeah? And we're saying that this is included, this is not included. Okay? There's a hole over here. So now, in the red, we're saying that it can go like this. In the white, we're saying it only goes like this. Okay? Now, I don't think this is a situation of combining both, but I think this is a situation of taking values on both sides and seeing what the output would be. We ask which values of x can be validly plugged into the equation that defines f of x. In order for the value of f to be defined as a real number x, the value of x must make the quotient underneath non-negative and the denominator non-zero. Thus, the domain f of x is a set of real numbers that simultaneously satisfy those two. The only values at which the quotient and the equality can change sign are x half and x equal to minus 1. Since those values can either make the numerator or denominator equal to 0. To determine the intervals on which the quotient is positive or negative, we only need to check the sign between possible change points. For example, so if I wrote minus 2, so then it will be I'm guessing if I plug in minus 2 into the original equation, which is this, or I guess which is this, anyways. If I plug in minus 2 here, minus 2 plus 1 is going to be minus 1, which is going to be not equal to 0. And okay, no, he's putting it into that entire thing. Why? Okay, I'm not really reading this, am I? The only x values at which the quotient in the equality can change sign are x equal to half and x minus 1. So those are the values which either make the numerator or denominator equal to 0. Now remember, we have to remain positive. If you go negative, we lose. We have to remain positive. So, if we change the sign to minus 2, then we see 1 minus 2 minus 2 over minus 2 plus 1 goes to be 1 minus 4, 1 plus 4 over minus 3 minus 1, which is negative 5. We lose. That's negative. Over here, if we pick 0, that's going to be 1 and 1 over 1, which is 1. That's going to be pause. We win over here. And then over here, if I picked 1, that's going to be 1 minus 2, which is minus 1. And then minus 1 over 1. Minus 1 over 2 is still negative. So we lose over here. So we have to remain in between here to here, touching this but not touching that. So therefore So now we're here. Since the quotient in question is negative on minus infinity to minus 1 and half to greater than half to infinity, the function of x is not defined on those intervals, because in those intervals it will be imaginary. Note that x half is in the domain of f, because there's no problem taking the square root of 0. However, we cannot take, since we cannot divide by 0, the function is not defined at x minus 1. Therefore, it's going to be minus 1, so it's going to be minus 1 half, not included here, but included here. Okay. Right. solution sets of these equations. These don't look too difficult. I don't know, we'll have to see. The last one looks the scariest. So this is x6. So now we're gonna have oh shit, wait, what? Oh, okay, no, okay, wait, never mind, this is easy. Sorry, okay, there is no x value here. Okay, it's not too bad, that's going to be 2 and no, minus 5 and minus 6. So that's going to be 5 and 1. Oh wait, 6 and 1? Minus 6 and positive 1? Then we're having minus 3x squared plus, minus 7x plus 1 equals to 0. So then we're going to have minus 7 and 3. So that's going to be okay. We're gonna have to use a quadratic now. Gives me quadratic vibes. 3 minus 7. 3 minus 3 minus 7 and 1. Yeah, we are going to have to do that. So x is equals to so minus b plus minus, so 7 plus minus square root b squared 7 squared minus 4 3 1 over 2 3 square root 7 squared minus 4 3, that's going to be 7 plus minus root 37 over 6. Now remember, we're not saying this is a function. This would be crazy if this is this is not a function. This has to be a formula, it's not a function, because since we're having plus minus for x, an input of x is going to have an output of 2 y values. That's not, no way. Okay? So, wait, no, I'm stupid. There are 2 values of x which have the same y value, not one value of x which has 2 y values. Okay? So root 37, and then that's going to be, yeah, so you're just going to have 7 plus root 37, 7 minus root 37. Do they give you, they don't tell you to do anything. I don't really want to do it anymore, we'll just keep it at that. And then c is going to be, we have to take out x. Huh? No. 32 can be broken down into 1, 2, 4, 8. and 32. Of course, plus minus for all of them. So now 2 times 2 to the power of 4 is going to be 32. So now, therefore x would therefore this would be it. Okay, so essentially you're just having this, right? And you're saying that, we'll call this g of x. So therefore g of 2 equals to 0. Okay. Therefore x minus 2 is a factor. So therefore we're not going to say y equals no way. What we're going to do is just so then oops, what am I doing, dude? Right? So wait a minute. What? But x minus 2 is a factor. Is x minus 2 not a factor? And I just wasted all this time? 2 times 2 to the power of 4 is equals to 32. And that's going to be positive 2, so we're going to be looking at minus x minus 2. Brother, minus 4x cubed, then minus 4x squared, so you would get minus plus 8x squared, and then you have to get rid of the 8x, so then 8x times x, and 8x times minus 2 is going to be minus 16x. Minus 16x is going to be removed by minus 16 times x. You're getting minus 64 at the end. So minus 16 times minus 2 is going to be plus 32. Minus 32 minus plus 32 is going to be minus 32 minus 32 is going to be minus 64. So it's not a factor, but it is a factor at the same time. I don't know. I have no idea. You can take 2 out. Yay! Face on. God. Yep. Sorry, Kirza. Oh. Yes. Okay, so this is what we're supposed to do. 2x x4 minus 32 minus 16, and then think of this. No in between, so yeah. No, wait, whoa, hold on. Pluses can't have it, but minuses can, because that gets turned into x plus 2 and x minus 2, right? Yes. Yep. Therefore x is going to be equal to 0, minus 2, 2, and whatever the hell this is. Does x even have a value here? Yes, 2. So this. Check the answers, just substitute your answer back in and just get a 0. Hope to get a 0. Please. Gold. How long have I been doing this for? 2.5 hours, not bad. I didn't time a single second of it. Sweeto, no? I'll just keep the timer on then. Actually, I do not give a shit. Not right now. You wanna do one more example? Let's do one more example. So it's gonna be x. 7. Before, is everything else before that correct? 7 plus minus 37. And the top one is going to be negative half and 3 and 0. So calculate the average rate of change of the function this, a on the interval this, and b on the interval this, and then illustrate these average rates of change graphically. For this one, you have to use the thing that we learned in Unit 2, right? Okay, I'll do this later then. See you.